Hi everyone, I'm Mohammed and I'm working as a data scientist since 5 years ago. You know one of the most important challenge in the data science project is data engineering. It means we cannot imagine data science without data engineering. And data engineering in simple words is a matter of extraction and transformation and loading of the data. In this process, we are going to clean the data, transform the data in readable format for the data scientists. In this tutorial, I want to explain you a simple ETL process which use Python languages and Pandas data frame and postgreSQL as a database for the ETL process, and later pgAdmin to connect to the database and having access to the old data tables, and Grafana for the dashboard. And the whole pipeline is working with the Apache Airflow, but I'm going to put it in the step by step from the beginning. If you don't have experience with the Apache Airflow or Grafana or pgAdmin, stay with me. I go step by step and show to you how to use Docker container to run all of these services easily and connect to each other. So first, let's start with this part that we want to extract and transform the data. In this script, I want to connect to this URL, which the Corona dataset is uploaded daily. There are a couple of files there, but the most important file regarding our project is confirm case des recovered one. And if I go to one of them to open for you, for example, for this confirm one, we can see on top there exists a different column: provenance or state, country, latitude, longitude, and the different dates. For both datasets that we download, we always have some information like that. And the difference in this file for each day is it ends one column at the end of this CSV file, which belongs to the new date. Back to the script, we can go to see step by step what we want to do. First of all, I want to download this file, and when the data is ready, I want to show in a proper format instead of having many columns with the date's name. I want to arrange them and put as one date column. At the end, I want to load to the database. For ease of use, also I'm using a Jupyter notebook to show you a step by step what do I mean. So let's running the first script. In this script, it's connect. We are using the wget library, and it downloads the file and put in the data folder. When the data is ready, then I can go to process each of them. First, I'm reading the data. I'm grouping by the country, because for some countries we have different records according to the different state. Then I just want to get a sum over country. We don't need the longitude and latitude, and also because the CSV file contains the cumulative sum, it means each day the number is equal to the previous day or increasing. It doesn't show the new cases. Simply, I'm using the diff function from the pandas, and then I'm melting based on this country region and putting all the dates into single column. If we want to look at the final output, it's something like that. It means I want to keep the country as it is, and instead of having many columns with the different date, I'm bringing all of them in one single column, which is date. It's the thing that I'm doing in this function. And also the date format, if we look at the data again, we see the year has 2 digits, not 4 digits. We expect it to be 2020, 2021, but it's 2 digits. Also, we need to convert that. And it's the reason I'm splitting this column, and then I'm adding 20 at the beginning of them and creating a data frame, the Panda data frame. And at each time, I'm adding all of them in one single file, a single list, and when they are append to each other, I'm merging them. And then we have this table in final output. So it's all of this thing which is located here. Just for ease of use, I use a Jupyter notebook that you are able to see the intermediate result. Now the extraction is done. We did the transformation. We have a ready table to transfer it to the database. But before going to see how to transfer this data to the database, let me to show you a Docker container. For all of these services, we want to use a Docker container. I don't know, are you familiar with that one or not? But it makes the whole process much faster and easier for us. There are a couple of Docker containers that we want to use, but I start with these two containers. One is the TimeScale DB, which is based on the postgreSQL. And when you go to this web page, TimeScale DB, you can see it's a postgreSQL plus time series. It means for the client, they do not see any change at all. They can use the same query as they had before to connect to the Postgres database, but in the background, it's highly efficient for time series data. And another one is a pgAdmin. It's one of the tools you can use to connect your Postgres database, and it gives you many GUI tools. Back to the code. It's simple to run. We can say Docker run, then we say which kind of port mapping do we need, what is the password for the Postgres user and the database. And if we want to map a volume from our local machine to a folder inside the container, we can use this V option, and we can assign a name and say, okay, when something happens, always restart the system, and which repository or which images to use for this container. The same we could have for the pgAdmin. We need to assign a default email and password, and also assigning the name. You can find all of this code and a script inside the repository, which you can find here. You can go to the GitHub, my repository, mdkatami, and for this project, you can find all the file and a script inside the Corona -ETL. Let's open the terminal. I'm going inside the project here, the path to project, and by typing docker ps, we see, okay, there is no running images here. Then let's start our first container. The image exists because I downloaded this image before, and the process is fast, and now it's running the TimeScale DB for us. I can do the same and just going to copy this command to install, to run the pgAdmin service as well. Let's type docker ps again, and now we can see we have two services. One is the pgAdmin, one is Corona TimeScale DB. They are running, and we can see the port as well. Let's check to see is it working or not. First, let's start with the pgAdmin. We say, okay, from the local host, map 5050 to port 80. Let's go to our browser, and I say localhost 5050. And when I type this one, it shows us the logging. And then I can say, okay, the username is mdkatami Gmail, and the password, which was super secret, and let's log in. And when we connect to these services, we can create a different user for the different user that we have in our company or in our project. And each of them should create their own services. Currently, the server is empty, and we are going to create these servers. Back to our code. So now we see the data is extract, transform, and let's go to transfer the whole data to the database. For this one, I put all the function regarding the database inside the utils file. I'm using the psicopg2 as a library to connect to the database. For this one, it has a simple function of connection. Then you need to assign database name, user, password, host, and port. And here is a dictionary. I'm putting all this information, then I don't need to change each time inside the code, and I put as one variable here. With this function, we can connect to the DB. The first function that we are going to call is initialization of DB. At each time that we call this function, because it's not a too big data set, just for ease of use, as this example and tutorial say, if the table exists, just remove it and create a new table to transfer the data. But in reality, we don't need to each time to drop this table. So first of all, I say create the extension TimeScale DB. As I mentioned, TimeScale DB is a kind of extension on top of the postgreSQL. And sometimes when you create a new database inside the TimeScale DB, maybe the TimeScale DB extension, it's not activated. And then you need just to call it. And it's the command to do that. We are looking for this table Corona. If exists, we want to drop it. And else, we are going to create a table like that one, the country, date, confirm case, death, recovery. And we define a primary key as a combination of two columns, country and the date, because we should a separate one. And the magic from TimeScale DB comes here. When you have a normal table, you need to convert it to the hybrid table to be efficient for the time series query. And we're doing that like this one. We say, select create hypertable. It's a keyword, which table and on which field as a time. And then we run all of them. So the initialization is running, and imagine that you have a data frame, pandas data frame, and you want to load it into the table name. Here in our example, df is a panda data frame and table is Corona. We simply save the CSV file on disk and say, okay, use this kind of separation. We don't need the index and header. And when we have NA value, just replace it with none from the NumPy. Then we connect to the database and we say, transfer this file to the Postgres. And this function, using directly from the file to write to the PostgreSQL, it's really fast. I put here another function, which is batch load. We can call line by line, but as you know, because the iteration is not very fast in Python, it takes a long time to transfer whole data into the database. The good thing for this one is you can check for each new data that you insert. Then the combination could be a good usage. It means when you have a big file, you can first using the load to transfer this whole big file to the database. But later for the new update, just you say, okay, for the data which doesn't exist in the database, then going to use this insert command because you don't have too much to insert. So let's go to this code and run and make sure it's running. So it's going to download the files, the first one, second one, and third one. Now we are merging the data, the different data that we have. And now the loading is done. It means all the data now it's written in the database. So let's back here. We want to connect to our database. In the Docker PS, we have Corona TimeScale DB, and I can say Docker inspect our TimeScale DB. From here, from the network, I'm taking its IP address, which we need, and let's back here. I say I want to create a new server. You can assign any name that you want. I say Corona DB, and for the connection, I say here is the IP address that I want. Which port do we want to use? What is the maintenance database? The username is Postgres. Password is Postgres. I want to save the password. And let's say save. And if everything is successful, then you can say, okay, it shows the transaction and other information. Let's go to the Corona DB database. As we see, we have a Corona DB here. We can go to the schemas. These schema, except the public one, you don't see in the normal PostgreSQL. It's added because of the TimeScale DB. It's added the new additional information to make this time series efficient table for us. When we go to the public, we can see different section like the aggregation, domains, and different information, but our table is located in table. We see one table exists kernel, and I can simply say, show me the last 100 rows from the table. We can see the query here, and then also we can see the country, date, confirmed this. As it's the last one, we can see here the Zimbabwe as it starts with Z. And also when we look at to the date, we can see the almost the new date here, which is the January 18, the date I'm recording this tutorial. So let's back to our pipeline. We could extract the data with Python. We use pandas to transform the data, and we load everything to the Postgres. So also we could use this pgAdmin to connect our database. The most important phase is done. Now let's bring everything to Apache Airflow and to automate this process that each date going to do all of this task automatically. Then let's continue to our tutorial. When we go to Apache Airflow, it's a kind of tools written which support Python. You can easily run your Python or any other script. We can go to the installation page, Airflow Docker. So in the official documentation, we can see there is explanation how to configure your Docker. They provided a Docker Compose file. We can download this Docker Compose and use that one to run our Apache Airflow. For ease of use, I created my airflow.sh. Just for each time, instead of going to create this folder manually, here I put a simple bash script. I say, remove this folder as it suggested, create these folders for me, DAGs, logs, plugin, and data. And I put the backup of my code here in, as two sample file here. And also the backup of the Docker Compose. The reason that I'm not downloading directly this Docker Compose is I modified a little bit this Docker Compose to work with that one. Let's go to this Docker Compose to see what we have originally here and what I did add to this file. When you go to this Docker Compose, you can see many information and nice description from the Apache Airflow. One thing that it suggested is there are three importance folders, DAGs, log, and plugin. And it suggested from Apache Airflow to map them to your local folders. Besides that, because I'm downloading some data, I also want to map this data folder to this folder. The reason that you want to make them separate because it becomes later easy when you want to work. For all of your workflow that you have, you should put the script inside the DAGs folder, and Apache Airflow automatically detect this file. Besides that, as I mentioned, Apache Airflow is a very good candidate for your pipeline workflow. You can also install your Python library. If you want to do that, you can simply put the name of the library that you want here. And as example, I put the wget here, which is going to install this library for us when we are running the Apache Airflow. Apache Airflow has a different container. It has its own database to store all the log file inside the database. And the different services. But like the Redis, Airflow web browser, Airflow scheduler, I didn't change anything here, but I just add my own services, which is TimeScale DB, this service, Grafana, and pgAdmin. Because this Apache Airflow is running on its own network, I also want to put my own container, which I want to use later inside this Docker Compose. It's the reason I told you that I changed a little bit this Docker Compose file. So if you want to use any other services to be connected to Apache Airflow network, you can simply put your container here. It's the three container I added here: TimeScale DB, Grafana, and pgAdmin. So everything is ready. I'm going to this terminal, but it could be a little bit time consuming. Let's delete the existing Docker, which we don't need anymore. Docker stop pgAdmin. I want to stop pgAdmin, and also I want to remove it. And also I want to stop my TimeScale DB. Back to the name, here is Corona TimeScale DB. Corona TimeScale DB. And also I want to remove this one. Okay, that's all. And when I say Docker PS, it means we don't have any running container. And I want, first of all, to run this script, my airflow.sh, just to make sure, okay, all the folder are removed and recreated again. Let's go to here, and I put all of them. I did all of them, and it says start with Docker Compose up Airflow initialization. So we can say Docker Compose up Airflow under minus init. So it's looking for the images. If it doesn't exist, it's going to download them. It could be time consuming when you run it for the first time, and we should wait till it's end its process. While it's working, we can go to the script again, and I can explain for you how to create your own DAGs. DAG structure, it's so simple. I want to convert this load Corona DB, which we saw with each other, which shows a different function. They are connected to each other. I want to bring this load Corona DB and utils into the single file here, Corona ETL. The last part is just related to Apache Airflow, and the rest is pure Python. As you see, I'm putting the same library as before. The way that I'm connecting to the database, everything is like before. And I do not change anything except that here, just downloading the data, I'm going to download it with the curl directly. So when we have all the function, now it's the step to define our step in DAG. The first step is extraction. Here is the way I'm defining. I say extraction is a kind of Python operator. Here is the ID name, and here is the function that we want to use, extract Corona data. When we go to this function, it's nothing except the function that we saw before. And then again, for the transformation, we say, go to the transformation of the Corona data. Then again, it's going to read this data, look at this address. I'm using this one, Apache Airflow data, the way that we use the pass to the data. And also at the end is loading, and it's located in the load Corona data, and we can go there to initialize our database and so on. So, and here at the end, we show the order, the way that this script should be run. It means transformation starts only after the extraction is done, or the loading starts when extraction is done, transformation is done, and loading is start. It's so simple to create your own DAG. Back to the terminal, okay. The initialization is done. Now let's say Docker Compose up. So we can see the different services that we have: pgAdmin, Grafana, TimeScale, Redis, Postgres, all the services that we define in Docker Compose file, which makes the life much easier. And we should wait till it's running. When we back to this Docker Compose file, let's look at it together. We can see the different services that we have. One of the services is Airflow web server. As we can see here, the port matching is 8080 to 8080. It means when the Airflow is ready to use, we should go to this port 8080 and we can access this one. Currently, we cannot see anything here because the service is not running now. As I mentioned, it takes some time, and it's the reason that it suggested that you need at least 4 GB of RAM to be able to run all of these services. You can do much more complex tasks with Apache Airflow, but just for ease of use, to have a beginning introduction to Apache Airflow or ETL process with advanced tools, I just choose a simple example to do that. But when it's loaded, I can go through some of the example. We can see the example that we can do much more. Then let's wait till installation is done. So now the code is running. Apache Airflow also running. Let's go here. I just to test it, I logged in before, but when we go to this page, localhost 8080, it asks for us for, let's log out. It asks for the username and password. The username and password is Airflow. Let's sign in. And when we go here, we can see many examples here, which is provided by Apache Airflow, and you can go through them to learn. And here is our DAG, Corona ETL process. When I go there, we can look in the graph structure or the tree structure, and it has many more options. You can go through them to explore them. But we can see automatically it shows the different steps that we have. And the type of the duration that we put, it shows, okay, how often it should be run. In our code, when we go here to the definition of this DAG file, here we mentioned that the schedule interval is 4 hours. And when we go here, we can say, okay, it's run each 4 hours. We can change this parameter. We can put, okay, when is the starting time? And when you load your script, make sure that it's not paused and make sure it's activated. Let's go here, and here it shows a different run. We can go through them for the debugging, but let's manually trigger it and say, I want to run this pipeline. Simply I say trigger DAG, and then it shows with a different color. It starts now with the green, light green, it shows it's running. The first step is done. Dark green means success. Now the second step transformation is working. We see with this color running, it's done. Going to the next step, loading to the Corona database. So 3 steps are done, and now the color is changing to this one. So it means all the steps are working. Let's go to the pgAdmin. When we go here, let's go to the new tab and say Docker PS. We see all these running services, Corona, Workflow, Grafana, and other things that we see here. I'm looking for pgAdmin, and let's find this one. Web server, trigger, flower, pgAdmin is here, and we set the port matching to be from 80 to 80. Then let's go to the local host and put 80. As you remember from the previous run, previously I run on port 5050, now I on port 80. You have this flexibility to run on any port that you want, which is, of course, it's not used by any other program. Let's connect to this port. It asks for the username and password. I'm putting my username and password here. And then for this one, I can put super secret here, and let's log in. So now we don't have any server here. Let's create our own server. So back to this terminal again, I can go to look at the IP address or try with the name. Let me to first try with name. If it's work, we can leave as it is. So let's copy the name. I'm putting Corona DB. It's the name that we assigned, and here is the name of the host. And all the passwords like before, Postgres, save password. And let's see, yes, we are connected. Let's go to the database that we have from the Corona DB, going to schemas, which we saw previously, and we can go directly to the table. And here is the Corona data, and let's say, give me the last 100 rows. So congratulations. Now we have all this data. We run the whole process with the Apache Airflow. We are using a different services and tools here. We are using TimeScale DB. We are using the pgAdmin, Apache Airflow with the Docker. We can do all of these things easily. And now we can see we are all connected to Apache Airflow and the our GUI to connect into the SQL database. I just updated this part. I noticed, okay, this part was missing, that when we are saying the loading the Corona, we want to initialize this one, say, okay, here is the path to the merge file and load it. It's like before, but I just forgot to update in the Corona ETL file. So that's all. Now let's look at also the Apache, also to Grafana. We also install Grafana. We can access Grafana on port 3000, localhost 3000. So, and then I'm adding a username and password. By default is admin. Then you can set your own password. Then I'm just assigning my own password. Oops. So, and when we go to the Grafana, you can find many documentation on its own web page. There exist many samples, but I'm just going to create a very easy to use and sample dashboard. First of all, we need to connect our data source. There are different data sources you can connect to the Grafana. One of them is postgreSQL. Then it asks what is the name that you have. You can say, okay, it's Corona database, and then you can put the name and port. It's the name, and here is the port. It says, okay, which database name do you have? And let's back to here. Our database is Corona DB. Putting the database, our username is Postgres, password is Postgres. We can disable SSL mode for the time being, and it asks for the version. We are using version 13. It's TimeScale DB, and we can save and test. Okay, now we are connected. Let's go to create a new dashboard. When we go to this dashboard page, we can say, okay, it's empty. We can create our own panel. We can add as many as panel as we want. We can go to create a panel. Here you can see a different type that you want to create: time series, bar chart, and different information. Let's stick with the create a very simple time series data. Here I say, because it's activated, this data source, when I go here, it automatically detect the different table. I say it's Corona, and it asks which columns contain the date. I say date, and then I'm saying, based on the country that I want to see, it says which column do you want to see the information. I say this, and as we see, we don't see anything here because it's a last 6 hours. Then I can simply change it to last 30 days. And then we can see many information here. For the different country, we can all this information. And it's a good thing about Grafana. It always using this time filter. It means this variable automatically created by Grafana. And when you are going to change this part, you don't need to change your SQL command. So back to this query builder, we can change many parameters here, but let's put, for example, expression I want. I want to say when country is equal to Germany. And I want to look at for data for Germany. Then we can see this data. And also I want to put some Windows function. I can say I want a moving average, and it shows a moving average of 5. Let's change it to 7. We have this kind of moving average. Or you can simply say, I want to be country inside in the different countries. Or you can create your own SQL command for this purpose. The good thing is you can, at each time, you can look at the generated SQL one, you can go to change this SQL, create your own SQL, and so on. And then we can apply, and now we have this panel. We can go easily to create another panel showing the bar chart and so on. So let's create another panel. For this one, I'm going to say add panel. And previously, I played a little bit with the SQL command that I want. I want to show just only some of this country, not all of them, which has the highest amount of this. And for this one, I'm going to use something like that. And let's go to the code and we can see together. Let's discard this one. We can remove it and going here and I say, let's edit this one. So, and then here, instead of saying this, I can say, instead of saying to equal to Germany, I want to say inside. And then here I can just copy and paste the command that I have. Then I can say just showing the country which is inside this one. So I say selecting country from Corona, where I'm just keeping this time filter. It means I don't want to look at for the whole time. Just I'm saying in this time filter, which is activated from here. Grouping by country, ordering by sum, and just I want to pick the top 10 country. So let's skip this one. Now we can see this how this information is changing. It means when we change this time frame to, for example, to last 7 days, it's going to update according to this time frame. I don't need to change anything in my code because I'm using this time filter data, or last 30 days. Here are some options you can use to add bottom. You can change the shape. How do you want to present them? Which kind of line interpolation do you want to show? You can change the line width, or we can go to show as a kind of a logarithmic, and it becomes easier to see all countries. We can have access to the different data that we want to see. You can do much more. You can go to create as kind of exercise to create a different bar chart, heat map, or anything that you want which match, and to show them. Simply, we can say, okay, apply and save, and we can see this one. And when you add as much as panel that you want to have here, and simply you can always switch. I can say, I want to see the last 6 months, and then see, okay, how the country is changing. For example, this line for Indonesia, and we can see how the number is decreasing, and we can see many nice information here. Just it was a simple introduction to Grafana to see how simply you can create your nice dashboard. I hope that you enjoyed this video and tutorial. We use a different services here to do a ETL process with Apache Airflow with the help of the Docker container. And if you like this video, please like this video, and you can find me on LinkedIn. Thanks, everyone.